Hello everyone! In this video, I'm going to present you what we call an anatomy of a vent explosion. What is happening during a dust explosion in a closed vessel? Which are the several terminology for each key points used to explain it? During a dust or a gas explosion, there is a curve effect, which starts from the ignition source to the maximum pressure created by the explosion, the highest point on the curve before the curve decrease. By installing a venting solution on a vessel, we can see what effect it has on this curve. Let me introduce you which are those key points. A dust explosion is a chain of reactions which start from an ignition source and goes to a top point, which is called the Pmax. By installing a venting solution on a vessel, the curve effect is significantly different. Indeed, a venting solution, like an explosion vent panel, avoids the explosion to reach its maximum pressure, the Pmax. Pmax is the synonym for the maximum pressure that can occur during a dust explosion. It is measured in a laboratory. Actually, when a dust cloud burns in a confined vessel, there is a rate of the pressure rise called dP on dt. In other words, it is how fast the explosion goes from zero to its Pmax. Another important keyword when we talk about dust explosion is the KST. KST is the deflagration index for dust. The KST test results provide an indication of the pressure rise at a dust explosion, and it is a value which comes from a special test vessel, like this. The larger is the value for KST, the faster is the explosion. The main purpose by installing a venting panel or a flameless venting, like this, on a vessel, it is to make a weak point in order to relieve the pressure before it reaches the maximum strength of the vessel, called PES, pressure enclosure strength, in addition to being able to guide the pressure in a safe direction. Respectively, we talked about Pstat, static opening pressure of venting device, and PRED, pressure reduced. It is the maximum internal pressure of equipment during venting set at maximum of 75% of ultimate strength of enclosure, the PES. Let's do a short resume about the key points we just described. The KST is the deflagration index for dusts, volume-independent characteristics. It's always indicated for pressure rise in a 1 cubic meter vessel, which is calculated using the cubic law equation. dP on dt, maximum rate of pressure rise, highest value of the pressure time curve, measured in a closed vessel during the explosion of a specific mixture. Pmax, maximum pressure reached during an explosion in a closed vessel. PES, pressure enclosure strength. PRED, pressure reduced, maximum internal pressure of equipment during venting set at maximum of 75% of ultimate strength of enclosure. Pstat, static opening pressure of venting device. Thank you for your attention. Stay tuned.